Hello and welcome to EXFO's Be an Expert training program on voice frequency and wideband noise. Today we'll be discussing the different types of noise, so VF, voice frequency, WB, wideband, and their respective PSD, power spectral density, and impulse noise tests. We'll be discussing what they are, the difference between them, how to measure them, and how to use results to recognize disturbers using EXFO's MaxTester product line. First, we'll begin with VF noise. Anyone who spent some time troubleshooting voice telephone circuits has at some point heard a noisy telephone line. Whether it's a buzz or hum on the line, or hearing a neighbor's gossip with crosstalk, it's very simple to tell that something is wrong just on the fact that we can hear it using our ears. In the case of wideband noise, we need to rely on an instrument that can listen for noise at frequencies of up to 30 megahertz, essentially listening for any sound that's present on the line that would create a disturbance or impede the communication between our DSLAM and modem. A simple analogy I like to use is this. Right now, if you were to take a second and just listen to the sound in the room, there's any number of things that could be generating a constant noise. There's most likely an HVAC system with fans or air flowing through them, or there could be a computer fan or even a noisy, buzzing fluorescent light. All of these items can create a measurable noise, and this is the type of noise VF noise and WB PSD noise are testing for. Listening to the constant noise on your cable pair and reporting it back to you. Obviously, if things are quiet enough, we're able to communicate with colleagues, listen to this video, talk on the phone, so any little bit of noise isn't going to bother anybody. However, if things get louder, so let's say there's a group of people carrying on a loud conversation or the fire alarms are going off, this noise now impedes your ability to listen and speak. In DSL terms, this now limits your rate reach capability or lowers your signal to noise ratio to the point of taking DSL errors because the DSLAM and modem are having communication issues. It can even become loud enough that no matter how hard you yell, you simply can no longer communicate with anyone. Using the WB PSD noise test, we're able to listen to the cable pair into the DSL frequencies and determine if this circuit is capable of transmitting the constant conversation between your DSLAM and modem. In the case of impulse noise, the example I like to use is being out to dinner with family or friends, and in the middle of a conversation, someone accidentally drops a tray and breaks plates or glasses. Obviously, when this happens, the loud crash disrupts any conversation and you either need to repeat yourself or just start all over again. This is the type of noise we're looking for with the impulse noise test, except in this case we're sensitive to microseconds. All it takes is a short noise that comes on the line and is so loud that it completely disrupts your communication on your copper pair. What we're doing with the impulse noise test is setting a threshold that says any blip of sound above a predetermined dB is considered an impulse noise and the counter increments. What it will do is listen for a minute or longer and just count each sound that goes above that set threshold level. The first step in noise testing is ensuring that we're connected to the line properly and that the line is in the appropriate conditions for the type of test we need to run. For the VF noise test, we run it against a quiet line. So you have a telephone number that you dial into, and the switch essentially answers the phone and stays quiet while you run the test. If you select the VF noise test, you'll notice a couple of options. First is the VF noise filter. For standards POTS testing, the C message filter is the option of choice. It essentially looks at the heart of the voice frequency and weighs the noise found in that band heavier than the noise found outside. Number 2 is threshold settings. This is where you would adjust the pass-fail threshold. However, this has already been programmed into the unit for you. When running the test, you go to the dialer tab first and you enter the quiet line and dial the number. You then press the back button to return to the VF noise test, and it should start the test automatically. The results should pop up fairly quickly, and you'll get a real-time view of the noise on a circuit. If the noise is above the set threshold, you'll get a red X or fail. If it's below, you'll see a green check and a pass. Once finished, you simply press the start-stop button, go back into the dialer, and hang up the line. For VF impulse noise, we again want to test against the quiet line. So we're going to connect the copper test leads to the demarcation and run the VF impulse noise test. Once in the test, you'll notice a couple of settings. Number 1 is VF noise filter. This is going to listen to the line and it will weigh the noise it hears differently based on the filter you've used. For POTS testing, we want to use the C message as it focuses on frequencies between 1 and 3 kilohertz. 2 is termination resistance, same as the VF noise at 600 ohms. 3 is the test duration. This tells the unit how long you should run the test for. The standards body says that 15 impulse noise hits inside 15 minutes is a failure. However, not many of us have 15 minutes to wait around while the test is running. So usually a 1-minute duration is good enough. So 1 to 3 counts could be acceptable. But any more than that and you more likely have an issue. Number 4 is threshold settings. This is where you'll set your low counter and your separation values for mid and high. To run the test, you'll select the dialer tab, have it dial the quiet line. Once that's complete, you'll press the back arrow to return to the test, which should start automatically. Once the test is running, you'll need to look at the high, mid, and low boxes and their associated counters. What's happening here is we're setting a low threshold and then adding a separation value. So if you only get low counters, the line is a marginal pass. So it may or may not be service affecting. It all depends on your customer and the line's usage. If you get mid, it's a fail. And if you get high counters, you've got a clear issue on the circuit. When it comes to wideband testing, we'll begin with the PSD noise measurement. For this measurement, we need to test against an open or disconnected pair. So you either need to go to the premises and disconnect the demarcation and then go back to the crossbox to test from the D-slam towards the premises, or you could do the opposite, opening the pair at the D-slam and going to the demarcation and testing towards the terminal. One thing to keep in mind is that most D-slam manufacturers have a pot splitter on the input of the DSL ports. So this means any wideband noise heard on your line prior to the D-slam is being filtered out. So we're only concerned about the noise between our D-slam port and the modem. Once you've got the tester connected and the PSD noise test running, you'll see a couple of settings which can be adjusted. Number 1 is bandwidth. This is telling the tester which frequency range you wish to test for. So the unit will limit itself to only 2.2 megahertz if you wish for only ADSL2+, or you could open it up in increments of VDSL2 from 8, 12, 17, and 30. The only downside to having it open to 30 megahertz is you're not really concerned with the crosstalk at higher frequencies if you're only troubleshooting an ADSL customer circuit. So you could, in a way, overcomplicate your repair or installation by worrying about unaffected frequencies. Number 2 is noise filter. What the noise filter is doing is affecting how the RMS value is achieved. What's happening is it's calculating the noise levels and weighing the noise spikes outside of the filter's range different than the ones inside the range. So a large noise spike at, say, 25 megahertz may cause your RMS value to fail if the filter is set to none. However, if you change the filter for ADSL2+, it will now pass as the 25 megahertz interferer has little or no effect on your 2.2 megahertz customer. Number 3 is termination resistance. This is just the resistance the tester puts on the line while measuring. 100 is used for ADSL and VDSL, 135 is if you're testing for SHDSL. The fourth option is peak hold. This creates a blue trace on your graph which shows you the highest level each frequency has achieved. So if you have a noise that comes and goes, you're able to see the highest spike in blue and then its current value in real time in black. The fifth option is threshold settings. This allows you to enable or disable the pass-fail RMS threshold and allows you to set the value as well. The sixth option is select graph. This simply lets you select the cursor so that you can manipulate it left and right, or you can zoom in and out. Now looking at the graph, with the tester connected to nothing, we can see our noise floor is very low, roughly negative 140 dBm per hertz. If we connect it to a pair, we can now see different noise signatures. So you can recognize ADSL as it stops at 1.1 megahertz, ADSL2+ because it stops at 2.2 megahertz. You can also tell where the upstream and downstream start and stop. When looking at VDSL217, we can see that it stops at 17 megahertz. We can also see the separation of the upstream and downstream bands. This allows us to know what types of circuits are in our bundle. You can also see if AM or shortwave radio is being picked up on your circuit. If you have a large noise spike at, say, 1050 kilohertz, it could be your local 1050 AM radio station. This information can now be used to see why specific bins aren't being used in your DSL graphs. When it comes to wideband impulse noise, we're again testing against an inactive pair and looking for spikes above the specified threshold. With wideband testing, there's no threshold set in the standard, but we need to keep in mind that with an IPTV circuit, even a single impulse noise hit can interrupt a DSL frame containing a video packet, which causes video impairment for the customer. Looking at the screen, we can now see some options. WV noise filter. This tells the tester which service we're testing for. So choose the service this customer subscribes to. Termination resistance, test duration, and thresholds are all the same as the previous test. Just with WB impulse noise, we have no separation value, so it's a single counter. Again, we just run the test until the duration is complete.